Okay, so I just want to go back over this problem that we did yesterday because there was a typo in here. All right. So we were looking at the integral of sine squared of x times cosine of x dx. We let u equal sine x, du equal cosine x. We said that if x is equal to 0, then u was the sine of 0, so that was 0. And then we said if x equals pi over 3, then u is equal to the sine of pi over 3. And here's where the big error is. The sine of pi over 3 is not 1. I was thinking pi over 2. The sine of pi over 3 is the root of 3 over 2. All right. So just, if I have a circle here and then I draw an axis, let me get rid of that arrow. I draw another axis here. Okay. So pi over 3 is this angle. So there's pi over 3. X equals pi over 3. So x equals pi over 3. And u is the sine of pi over 3. So that's the square root of 3 over 2. Okay, so that changes our answer. So now this goes from the integral from 0 to 1 to the integral from 0 to the square root of 3 over 2. Okay, so therefore, now we integrate, we get 1/3 u cubed. So this is supposed to be the square root of 3 over 2. When we plug it in, we get 1/3. But now we have to do the square root of 3 over 2 cubed is 0. Okay. Did we ever write the answer? I guess we did. Okay. So this is 1/3. And the square root of 3 cubed is 3 to the root of 3. And this is going to be over 8. Okay, so where did we get that? We take the root of 3 times the root of 3, that gives you 3. And then one more time gives you a root of 3. So you get 3 root of 3. So now these divide out. So your answer is the root of 3 over 8. Okay, so I wanted to just go over that because we made, that was a really big error. I shouldn't say it's a really big error. It's a really big error in the sense that it made our problem's answer so incredibly different than what it should be. Okay. All right. So now we're going to start the next section. And you guys know you have an exam on Thursday. The exam is in person. You are permitted, and I would suggest that you bring your quick study guide that you purchased for $6.95. I tell you, it is the best $6.95 you will ever spend. Okay, and in fact, you will probably use it for any other course that involves mathematics. You can use it as a reference. So, all right, let me see how many people are on here. 21. Okay, good. We're only missing one. We have 23 people in both sections of this course. I'm just setting up for my quickly attendance, so I'll be ready to do it. Okay. All right, so today we are going to be looking at integrals of logarithms and integrals that involve logarithms. Okay, chat. Okay, so integrals involving logarithms. So before we always talk about integration, we like to talk about differentiation. So I just wanted to remind you of our differentiation rules, okay? So if you remember, the derivative of the log of x is 1 over x. and the derivative of the log of u of x, so I'm taking the derivative of the log of a function, is 1 over u of x, but you have to multiply by the derivative of the inside function. I am telling you, this is going to be on the exam, all of this stuff right here. The integration, I'm not so sure about yet, but the derivatives, you must know them cold. Okay, so the derivative with respect to x of log base a of x, you still get 1 over x, but you get log a in the denominator. Okay. And then when you take the derivative of the log base a of a function u of x, the function u pops up in the denominator. We still have the log of a, but we have to multiply by the derivative. Okay, any questions? Because that's review. All right, again, that's 4 little 3x5 cards. I know y'all sick of me saying it, but until you do it, you're not going to know the benefit of it. So here is these 4 rules. You need to know them like you know your social security number. I hope you guys do know those by heart. You need to know these rules. Okay, so now that we've reviewed those rules, and those are not anything different than what we did before. Those are the same rules that we've been using. What I now want to do is I want to go into what our integration rules are. So let me just highlight this because that was what we did. And now we're moving on to something else. So we are now moving into our integration rules. All right, so these are integration rules that involve logarithms. So if the derivative of the log is 1 over x, then the integral of 1 over x is the log of the absolute value of x. We say absolute value because we can't take the log of a negative number. So we want to make sure that you're only taking the log of something positive. Okay, so this is the first rule, all right? And then the second rule is, of course, if I can, what was I trying to do? Why does that say type equation here? That shouldn't say that. That's got to go. Okay. So if by chance we have a compound problem, that means we have 1 over a function. The only way we can integrate that is if 1 over u, which is the u is in the denominator, but its derivative is in the numerator. Okay, so this is the anti-differentiation rule for our log. Okay, so for the first 2. All right, the anti-differentiation rule. All right, so let's do some examples. Some of these are going to be easy, instead some of them are going to get harder. Okay, so our examples. So the first example I have for you is the integral of dr over r. Well, that's simple. That's the same as saying the integral of 1 over r dr. That means that's the natural log of r, absolute value of r plus c. So it doesn't matter what the variable is, if it's an x, if it's a u, if it's a r, if it's dr over r, or integral of dx over x. So another way of writing this is the integral of dx over x is equal to the natural log of the absolute value of x plus a constant. Another way of writing this is the integral of du over u is the natural log of the absolute value of u plus a constant. So it doesn't matter the variable, if it's x or u or r, we still get the natural log. Okay, so the reason why we did that is, so let's look at a real problem here. So this problem is the integral. In the numerator, I have 2x plus 1. And in the denominator, I have x squared plus x plus 1 dx. Okay, so this is a problem where I can't just do it with basic, just the x. Now I'm going to do the same problem with the u. So just as a guess, can somebody give me a guess? It may be right. It may, I'm assuming it's going to be right because it's kind of easy to see. What am I going to let u equal in this problem? Use the most complicated part. So what would I expect u to be?
Squared plus x plus 1.
Oh, thank you, Tyler. So you said x squared plus x plus 1. I'm good with that. And then du. Go ahead, Tyler. You want to finish? What's du? Tyler, where'd you go?
2x plus 1.
2x
Yeah,
plus 1. Okay,
correct.
it is 2x plus 1, the whole thing dx. Does everybody see that? That's real important. It's the entire quantity of 2x plus 1 multiplied by dx. Okay, so now I can see that here's my u. Okay, that's all cool. So that right there is u. And in this problem, it worked out perfectly. 2x plus 1 times dx just turns out to be du. So this one's a really nice one. So this works out to be the integral of 2x plus 1 dx, that's du. And then x squared plus x plus 1 is u. Okay, so now once again, this becomes du, and this is over u. And we know that the integral of du over u is right here. That's the log of the absolute value of u plus a constant. So my answer, all done, is the log of the absolute value of x squared plus x plus 1 plus my arbitrary constant. Okay, any questions about that? Any question about that? All right. So what was the most difficult part of that problem? Can anybody answer that for me? If you were looking at it, what was the most difficult part? I'm not asking you, did you think the problem was hard? I'm asking you if when you first looked at it and you said, what am I supposed to do with that? Was the most difficult part finding u? Was it finding du? Can you give me any idea of what was the most difficult part of this problem?
Well, I'm not sure how we found du.
You weren't sure how we found
no.
du? Is that what you said, Tyler?
Correct.
But you gave me du.
No, that was another classmate.
Oh, okay. Well, thank you for responding here. Okay, so when we did du, all we did was take the derivative of x squared, which gave us 2x. We took the derivative of x, which gave us 1. And so its whole derivative is 2x plus 1. And then, of course, we have to use the differential that we took the derivative of u with respect to x. So this part right here, this differential is real important. That tells you a variable that you took your derivative with.
I understand now. Thank you.
You're great. That's awesome.
A quick
Okay.
question.
Yes, Johnny.
So when going from that du to u equals ln u plus c, you know how the substitution, I guess yesterday, you divided by whatever on that side to get it under to du, like 2 divided by to get it like 1 divided by
Right.
1.
I didn't have to do that in this problem. It was already laid out for me.
So
So
when you bring it over, it just crosses out that 2x plus 1 to the one up top.
it doesn't cross it out. It just gets replaced.
It gets replaced.
Yes. So here on this side, I have 2x plus 1 dx. But I already know by definition from this side what I did with it. So over here, I need to replace d at 2x plus 1 dx with something that's only involves u's. Okay, so I need to replace with u's. With something only involving u. Because I'm trying to get the x's out. I want x's out. So when I have this x squared plus x plus 1, I made that u. So then since that's u here, then it goes into the bottom there. That's what u is. And then since the whole thing, 2x plus 1 dx, is actually in the numerator, remember, note that this dx is multiplied by the whole 2x plus 1, which is why I have this parentheses. And that whole thing goes up here in the du section. So my goal is to convert. Thank you, Waleed. I think some light came on. I saw you get it. The whole idea is to take whatever you have in U and put that into the original equation so that I only have an equation in U, and my equation in U is going to be simple. So the equation in U is going to be so simplified, I can use one of these rules now. So I couldn't use one of those rules on this whole thing, but I can use it in that because it's simplified. Okay. So let's look at this next problem. Now this next problem is a definite integral. Okay, so it is the integral from 0 to pi over 3. And in the numerator, I have 4 times the sine of theta. And in the denominator, I have 1 minus 4 cosine theta. Actually, let's make it 8 cosine theta. Oh, there might have been a reason why I wanted it to be a 4. Let me think. One minus 8 cosine theta. It's just going to change the answer. It's not going to be bad. I can deal with it. Okay. So now as I look at this, I can ask you the question. All right, same question I asked before. When you look at this, you say, oh, okay, what am I supposed to do with that? It looks difficult. But if you look at you look at this and you say, wait a minute, I know that the derivative of cosine is sine and the derivative of sine is cosine. So somehow I have to use that. But the numerator looks like it's more of a derivative than of the bottom, because the sine won't give me a 1. So let's just take a wild guess and let's let u equal 1 minus 8 cosine theta. All right, so now if I want, I can move the 4 out, because you guys know I don't like constants. They stress me out. I need them to be gone so that I can just do the problem and deal with the constants later. 1 minus 8 cosine of theta. And I truly believe this is supposed to be pi over 2. Okay. All right. So now we need du. So you guys should be thinking the derivative of the cosine is negative sine. So I have a negative negative. So that's going to give me 8 times the sine of theta d theta. Okay, so now we're working at the second step. So notice at the second step, I have this part is wonderful. That's my u. And then du, well, oh, I forgot my d theta. I need the d theta. So du, well, du is 8 sine theta d theta. I don't have an 8 over here. So I'm going to divide by the 8. Okay, so Tyler, this is a case where there's no 8. If there was an 8 there, it would be perfect, but there is no 8. So I need to solve for what's left in the problem. And what's left in the problem is sine theta d theta. I don't worry about that 4 on the outside because I'm going to multiply the whole thing by 4 when I'm done. Okay. So therefore, I need to solve for sine theta d theta. So here's where I'm going to divide by 8. So I'm going to get du over 8 is the sine of theta d theta. And now I have exactly what I want. Now, because this happens to be a definite integral, I have limits, and I wrote 0 pi over 3 again. It's supposed to be pi over 2. I don't know why I keep switching it. Pi over 3, pi over 2, guys. Okay. So what I have here is I still have to do my limits. So because I have my limits of integration, notice I have 0 and pi over 2. I got to deal with that. Okay, so I now know that when x is equal to 0, u is equal to 1 minus 8 times the cosine of 0. The cosine of 0 was 1, so that is -7. And when u, cosine of, yes, that's right. And when u is equal to pi over 2, I'm sorry, when x is equal to pi over 2, then u is equal to 1 minus 8 times the cosine of pi over 2. The cosine of pi over 2 is 0, so this just becomes 1. Okay. All right, so now do I need to go back and go over any step before I substitute everything in?
I'm just confused on where is it? From u to du. I'm just confused on the signs. Like
Oh,
when
no
you turn
problem.
into-
Okay, so u, let me write this over here. U is equal to 1 minus 8 cosine of theta, right? So it's du. The derivative of 1 is 0, so I get -8. The derivative of cosine of theta is negative sine theta d theta. So I get du is equal to 8, negative gives me 8 sine of theta d theta.
Oh, okay, I get it now. Thank
That's
you.
Peyton, that's good.
Yeah.
Okay. All right. Anybody else have an issue with a step? Everybody seems okay with the step. All right. So now I'm going to plug everything in. The 4 stays there because that's the part of the problem. I have the integral. When x is 0, u is -7. And when x is pi over 2, u is just 1. So that was 1 minus 8 cosine 0. So I get 1 minus 8 is -7. 1 minus 8 times 0 just gives me 1. Okay. Sine of theta d theta. Oh, how nice is that? That is du over 8. And the last thing, 1 minus 8 cosine theta. Well, that was u. Oh, wow. This is so beautiful. Okay. Beautiful. I hope y'all see it's beautiful because now it simplifies so nicely. I can take the 8 out, so that's 4 over 8. So I get 1/2 the integral from -7 to 1 of du over u. And we know that. We know by fundamental theorem of calculus, the 1/2 stays here. The integral of du over u is the natural log of u, And then that gets evaluated from -7 up to 1. So I have 1/2. Then I'm going to get the natural log of 1 minus the natural log of the absolute value of -7. The natural log of 1 is 0. So this is going to give me -1/2 the natural log of 7, and I'm done. That's the answer. Okay, any questions?
Can you try one more?
I can. Okay, I'm gonna give you an easy one and then a hard one.
Excuse me.
Your question?
Yeah. I'm
Yeah.
confused about the last two steps.
Okay, the last 2 steps up here on the first problem, this problem.
Yeah.
Okay, are you good with the fundamental theorem of calculus part?
Yeah, I get that part.
Okay. So once you do that, then the fundamental theorem of calculus says evaluated at the top limit. So that's the natural log of the absolute value of 1. And then subtract off when you evaluate it at the bottom limit, which is minus the log of the absolute value of -7. So I know it's a bunch of things that look the same. I don't know. I mean, maybe if I write my log like that, then you might get it. The absolute value of 1 minus the natural log of the absolute value of -7. So it looks like a line, n, line, minus line, n, line. So, okay. So maybe if I write it like that, does that help a little bit?
Now I understand what it's saying, but when you subtract it, how you get ln 7 when you subtract it?
Oh, because this is absolute value. And the absolute value of 7, -7 is 7.
So the ln of 1 doesn't matter.
Okay, that's important. By definition, we have the natural log of 1 is equal to 0. So therefore, I end up with 1/2 times 0 minus the natural log of 7. Because this is 0. That makes sense now?
Yeah.
Okay. I'm glad you asked. My values are floating in the air. Come back down where you belong. You belong on this line. 0 minus the natural log of 7. Stop floating. Okay. Any questions now? Tremont? Yes, Johnny.
Could I walk through that third problem right there?
Oh, everybody's getting ready to do that while I take roll.
Okay.
Yep, I'm going to take roll. And I think I will give you a value. Okay, and I'm going to take roll while we do this. So let me All righty. How can we do this?
Professor Locke.
Can you hear me now? I was here. I was trying to talk, but my mic kept acting up.
All right, Edward, I'll go back and fix it.
Oh no, that's
You know
Jay.
me. You know me. I was looking in the mirror.
I know you were looking in the mirror. That's what I said. You didn't hear me saying, Edward, are you looking in the mirror? Answer for attendance.
No, I was doing my facial things.
Well, you need to do your facial thing at 11:45.
I got you. That's why you my favorite, Professor Locke.
No, that's all right.
Dr. Lott, I said I was here.
Oh, Dominique, I didn't hear you either. So let me go back. You're marked. Now you're here, okay? And Edward, you are now marked here, okay? I love this class. Y'all are bomb. I mean, this is the best Calculus 2 sections that I've had. This one and the other one I teach. Okay. All right, so Johnny said he wanted to take this one on, so I'm gonna let Johnny take it on. Go ahead, Johnny.
All right.
What's you?
Would be x plus 10x.
Okay,
And then the du would be 1 plus secant squared x.
you see how I wrote it?
Yeah.
Okay, that's important. All right, you need to transform your variables. So how do you transform it?
So I divide 1 to the other side.
You start off with x equals pi over 3. Then what is u?
It'd be pi over 3 plus 10x pi over 3.
What's the tangent of pi over 3? What's the tangent of pi over 3?
It is
The sine of pi over 3 is the root of 3 over 2. The cosine of pi over 3 is 1/2. So this would be the root of 3. Okay, x equals pi over 4. So u is equal to what?
pi over 4
Mhm.
plus 10 pi over 4.
Okay, so that's pi over 4. What's the tangent of pi over 4? Pull out that card, Johnny.
Pi over 4.
The tangent of pi over 4 is 1. So I went ahead and stuck that in because I don't want us to be held up too much. Okay. All right, so therefore we rewrite the integral. So when you rewrite the integral, what do you get?
Oh, it'd be
This is x plus tangent x. So what is that?
that's my u.
That's u. So that's good. That goes in the denominator. And in the numerator, 1 plus secant squared x dx.
That's the denominator.
What is that?
That's a numerator.
Yep. What is it? What did I put there?
Oh, 1 plus secant.
I don't want any x's in my problem.
Oh, du.
Du, I gotta swap it out. Good. Okay, so now pi over 3 down here, and it becomes pi over 3 plus the root of 3. So this is pi over 3 plus the square root of 3 down here. And then this was pi over 4. So this becomes pi over 4 plus 1. Okay, so what's my answer? Integral of du over u is what?
That is
That is the whole point of all this section.
E over U is ln
Absolute value.
the absolute value of pi 4 plus 1.
Just you.
Oh,
Just
just you.
Evaluate it from pi over 3 plus the root of 3 to pi over 4 plus 1. Okay, so now what do you get?
Okay, so I still use the ln.
Yep, natural log. Now I'm going to drop the absolute values because pi over 4 plus 1 is positive. So I don't need the absolute values. And then pi over 3 plus the root of 3 is also positive. So I can drop the absolute value. That's the answer. I'm done. Done with that.
I got another question.
Okay, squaring off my answers. I was ready to say, oh my God, I didn't finish this one, but there it is. Okay. Yes, Trayvon, was that you?
Yeah, where do we find the thing you talking about? They got like the answers and stuff.
Oh, the quick study guide. Okay, so let's see. Okay, so this is the website, www.quickstudy.com. If you order it here, or you can order it, you can find it in the bookstore. They're probably out by now. So if you go to products, you want reference and study guides. Now this is going, yep, and that's the one for chemistry. You don't want that one. You want, yep, there's the one for Spanish. Okay, so where do you put in the title? All right, so let's see. This is actually shop study guides. Oh, I can get 15% off. There's gotta be up, here's the search. Calculus. All right, so here's the one for calculus 1. Here's the one for calculus 2, equations and answers. That's the one I told you you could get, $6.95. Here's the one for calculus 2. I told you you could either get the calculus 2 one, or these two are almost identical. This one and this one, they have pretty much the same information. You see that little block right there, that little square block? That little square block tells you the tangent and the cotangent and sines and all that of all your functions. This one also has it, but it's on the inside. This one does a little bit more area. I like this one better, but it doesn't matter which one you get. So when you log in, I got 15% off, but if I pick this one,
You said you like this one you're on now more.
this one I like better, but they're both very good. Okay, but they're both excellent. So this one, they both have pretty much all the stuff. So you put that in your cart and they will mail that thing to you in no time. Or like I said, you can go to the bookstore, wherever. But this threefold thing This one has the cotangents and stuff. It has the formulas for the integrals and logs. This is sequences and series. We're going to be doing that at the end of the course. So sequences and series, we're going to be doing at the end of the course. Can y'all see that? Where I blew it up?
Yes.
Okay, so it does have the integrals for the tangent, cotangent, well, tan inverse, so integration, and then it gives you some formulas and stuff like that.
So that's probably the best one to get then, yes?
I'd like this one. Let's take a peek at the other one. It's just as good. The Calc 2 one, if I can, yeah, let's see. Let's go back and search for calculus. The Calc 2 one is also good though. I mean, it doesn't really matter which one you get. Here's the Calc 2 one. So the Calc 2 one, I like the other one. I think this one has sequences and series on the back. I'm pretty sure it does, but I definitely really like the other one. So in any event, that's what you do. Okay, and I'm telling you, people that have it say, oh, Dr. Lott, in the middle of the test, I forgot the integral of so-and-so. It was right there on the sheet for me. Now you have to know how to use it. You can't just think it's going to jump off the page and give you all the answers, but you have to know how to use it. Okay, are y'all back to my notes again? So you see integrals of tangent x, cotangent x?
Yes, ma'am.
All righty, let's do that thing. All right, so let's do those integrals. All right, so these are not difficult because we're going to use the fact that the tangent of x is the sine of x over the cosine of x. And the cotangent of x is the cosine of x over the sine of x. So when I do the integral of the tangent of x, I'm going to write it as the integral of the sine of x divided by the cosine of x dx. So for this problem, I'm going to let u be cosine x because the derivative is never in the denominator. So if you have a problem and you have to use u substitution, it's best to make u, but you have to make u what's in the derivative is never in the denominator. Okay, so du is negative sine x dx. So therefore I get the integral sine x dx is just negative du. And then this becomes over cosine x, which is u. So I get negative the integral of du over u. Well, that's the whole purpose of this section. That is negative the log of the absolute value of u plus a constant. All right, don't forget the negative, it came from the sign. So this is negative log of the absolute value of cosine of x plus a constant. Now, we usually change this because you know how cosine and sine run together, they're partners. We usually write this as, take the negative and we write this as the log of the absolute value of cosine of x raised to the -1 power. But that's secant. So therefore, most times we write as negative, I'm sorry, we get rid of the negative and rewrite this as the log of the absolute value of the secant of x plus a constant. Okay. So there's our first one, the integral of the tangent of x dx. is the natural log of the absolute value of the secant of x plus a constant. And if you do the same thing with the cotangent, you get the integral of cotangent of x is negative the log of the absolute value of the cosecant of x plus a constant. Okay, so there's two more rules for you to know. Guess you say, when we gonna stop learning rules? Well, when you stop learning. That's when we stop learning rules, is when we stop learning. Okay. So now we can use that. So integral of tangent is the log of the absolute value of secant plus x, secant of x plus c. And remember, the cos are always negative, so the integral of cotangent is minus the log of the absolute value of cosecant plus c. So those are two more 3x5 cards. Okay. All right. Now we have to review derivatives of exponential functions in order to do integrals of exponential functions. All right. So when we review, remember, integral of e to the x is the only function whose derivative is equal to itself. It is also the only function whose integral is equal to itself. So the integral, I forgot to review the derivatives. I think I forgot that part. I just gave you, I sure did. I forgot to review the derivatives. Okay, let me slide that in. Those are the integrals. Those are, I forgot the derivatives. All right, let's do it. The derivative with respect to x of e to the x is e to the x. And the derivative with respect to x of e to the u of x, I know I'm having a moment, e to the u of x is equal to, e to the u of x, yes, is equal to e to the u of x times du dx. And the derivative with respect to x of a to the x is a to the x log a. And the derivative with respect to x of a to the u of x is a to the u of x natural log a du dx. So those you should know. Please, 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 please make sure you know those. Know how to manipulate them. That's what you should know. Okay, so now I can do my integrals. After we did the review, this is integrals okay, so integrals involving exponential functions. Okay. All right, so there we go. So these are the integrals. So if the derivative is e to the x, then its integral is e to the x. If its derivative is e to the u, then its integral is e to the u, provided it's got du sitting next to it. The integral, the derivative of a to the x had a natural log of a next to it. So therefore its integral is going to have a natural log a divided underneath it. And the integral of a to the u du is going to be a to the u over the natural log of a plus c. Okay. All righty. First one.
Can you go back up for a second?
I can.
Thank you.
Here.
Yeah. Yeah, right there. Okay, that's good. Thank you.
Okay. All right, here's the first example. The integral of e to the u du is e to the u plus a constant. Number 2, the integral of e to the r dr is e to the r plus a constant. So those are just ones to show you what to do with the variable. Okay, so now suppose I have something like this. The integral of e to the 2x dx. Now 2x is now a function. So 2x is now u. So I'm going to let u equal 2x. And du is 2x dx. Is 2 dx, no x, I'm crazy. It's just 2 times dx. And I don't have that left in the problem. I only have dx. So I got to divide by 2 to just get dx. So dx is the only thing left in the problem. So I got to solve for it. So this becomes the integral of e to the 2x. Well, 2x is just u, and dx is du over 2. So pull the 1/2 out, and then I get the integral of e to the u du. Oh, well, that's fantastic. That's what I want. I got rid of everything difficult, and now I'm on something rather easy. Good morning, Mr. Shara Collins. How are you? So this is 1/2. E to the u just becomes e to the u plus a constant. So now I can go back and plug my u in. So I get 1/2 e. U was 2x plus a constant. And that, guys, is a beautiful solution. Nice and simple. Okay, any questions about that? Because it's get harder. Okay. Let's go on to yet another problem. Number 2. Uh-oh, don't want red. I want black. Okay, here's a fun one. Integral from 0 to pi over 2 of e to the sine of x. And then cosine of x is down here, dx. So the sine of x is in the exponent. Okay, so obviously, remember now we want the derivative to be where I can grab it out, just reach out and grab it. And I need u to be something that if it were just an e to the u, it would be a nice problem. So let u equal the sine of x. And du is the cosine of x dx. So this problem was just made to be nice. All right, here's u. What color did I use for you last time? I've been using green for you. Okay. Here's u. And then cosine x dx. Well, that's fantastic. that whole thing just becomes du. So I'm good with that. But we have a definite integral. So somebody tell me what I need to do in order to transform this integral into all u's.
Don't you have to like x equals 0 and then plug in the
Okay.
0 for the u?
Awesome. If x equals 0, what is u? U is the sign of 0. And what is that?
Zero.
0. Good. And if x equals pi over 2, then u is equal to the sine of pi over 2. And the sine of pi over 2, we're looking at that chart. We're going straight up. Woo-wee, up there, 1. Okay. So now we can transform our integral. So here, 0 stays 0. And pi over 2 becomes 1. All right, any questions about that transfer? E to the sine x becomes e to the u. Okay. And then cosine x dx becomes du. Well, that is fantastic because now I have e to the u du. I can integrate that. That's just e to the u. I have to evaluate it from 0 to 1. So I get e to the 1 minus e to the 0, which is e minus 1, and I'm done. Okay, any questions?
No, but I just want to point something out. So basically, like I'm starting to like really understand it now. So it's like you have like a definite integral. It's like you simplify everything until you can kind of get back to like, I guess like when you can get everything back to you. Like
Okay, yes.
Yeah.
So the only thing, some people teach the definite integral by doing the whole problem, going back to x, and then putting in the x limits. I don't teach it that way. I teach it way I teach it, I think, is more concise and clean. So once I transfer everything to you, I never have to go back for a definite integral. Definite integral meaning I have limits of integration. Okay, so so here, notice in this problem, this problem was not a definite integral. This problem was an indefinite integral. There were no limits. See that?
Yeah.
Okay, so there were no limits of integration. So when I got done, why are you doing that? There we go. When I got done, my integral had a plus c, right? Because this is the most general antiderivative. And I had to take this u back to x because that's the way the problem was given to me. But when it's a definite integral, you use the fundamental theorem of calculus, which means here you evaluate the function, you evaluate your antiderivative at your top and lower limits when you have a definite integral. So when I have a definite integral, not only do I translate the x coordinates, I also translate the top and lower limits. Once I translate the top and lower limits, then I can put them in. And then I have an evaluated problem. And I'm going to get a number, not a function, just a number. Questions? Okay, this one's a little tough. It's not too tough. In the numerator, I have e to the square root of x. That's in the numerator. And in the denominator, I have the square root of x dx. Now you have to remember too, guys, this is not research. So since it's not research, the problems are made to work out. If this were research, you could be trying forever to figure out an integral, but these problems are made to work out. So I'm going to let u equal the square root of x, which I know is x to the 1/2 power. So du is 1/2 x to the negative 1/2 power dx. Now, if I rewrite that, that is 1/2 times the square root of x dx. Okay. So if I multiply both sides by 2, I get 2 du is equal to 1/, the square root of x dx. And that is beautiful for me because here it is. Problems are made to work out. Okay. And u is right here. So this becomes the integral e to the u divided by this one. Oh, well, that's just 2 du. So my answer becomes, need just a tiny bit of space, not a lot. So this just becomes 2 times the integral of e to the u du. But that's just 2 e to the u plus a constant. And now I got to put u back. So this is 2 times e to the square root of x plus a constant. Okay. I'm not ready for you yet. The integral of x 4 to the 3x squared dx. Honestly, that looks hard. But it just looks that way because you got x and then you got 4 and then you got 3x and then you got squared and all that. Okay. Just somebody at least just start us out. So take a woosah and just give me an idea of what you think u will be, and you will see that the problem will flow in a minute. What do you think u will be?
Is it 4 to the 3x squared?
Okay, that's too much.
Oh, that's too much.
That's too much because that's going to make it hard.
Would it be 3x squared?
3x squared. So I'm going to let u be 3x squared. And du is then 6x dx. So I already know that this is u. I'm good with that. So I'm looking at 4 to the u. So we're okay with that. The problem is I have x dx. And over here, I need x dx. I'm gonna divide both sides by 6. So I'm gonna get du over 6 is now x dx. And I'm liking that because everything for my problem is substituted in. Okay. So now when I go back to this, this is going to be equal to 4 to the 3x squared becomes 4 to the u. And x dx becomes 1 over 6 du. So this is now 1 over 6, the integral of 4 to the u du. Now we haven't done one of those. We've done the e's. Instead of now, we still have 1 over 6. 4 to the u becomes 4 to the u divided by divided by the natural log of 4 plus a constant. So this answer becomes 4 to the u divided by 6 times the natural log of 4 plus a constant. Now, if you're saying, Dr. Lau, where did that natural log of 4 come from? That's because that's what I defined it was in the beginning. We'll go back. And I didn't honestly expect that you would remember it, but we're there. So let me go back just for a second. Here we go. So this is what I used. I used that. The integral of 4 to the u is equal to 4 to the u over the natural log of 4. Okay. May have time for one more. The integral, I like the number 4 today, so I'm gonna stick with it. 4 over x, the natural log of x, quantity squared, dx. Ooh, what do I do with that? What do I do with that?
Is it u for ln x?
Caleb, yep, okay, thank you, Caleb. U is going to be ln x.
And then the
D,
du is it 1 over x?
1 over x. Keep going. 1 over x, 1 over x.
Dx.
X. I need
Yeah.
that. I need that. We need that. Because we're trying to substitute something completely out. And we can't do that if we don't have you can't do the full substitution. Okay, so I think I'm done, which is good. We have only 3 minutes left. Here's u. Here's du, dx over x. 1 over x, dx over x. So that's a perfect substitution. All right, Caleb, do you see that?
Yes, I do.
All righty, awesome. So this is 4 times the integral. Dx over the x just becomes the du. And this becomes u quantity squared. So this is 4 times the integral of u to the -2 du. All right, that doesn't bother me. I know I need to add 1 to the exponent and divide by it. So this is 4 times, add 1 to the exponent, so I get -1, and divide by it gives me a -1, and add plus c to it. Okay. So when I'm done, I have -4 U to the minus 1 puts a U in the denominator plus a constant. So my answer is -4 divided by the natural log. X is the U is the natural log of X plus a constant. Okay. We only have one other type of integral to do. I think I will be able to get through that tomorrow. Tomorrow's Wednesday, right? Yeah. So I will give you one, we'll do this little bit of integrals involving log X. We can work on that tomorrow. Okay. All right, any questions? We did a lot of work today, but again, y'all think I'm crazy, but those 3x5 cards work. Okay, so you can remember how and when to use each rule. All right, any questions?
I have a question.
Yes.
Where did the -1s come from?
Because remember when you have U, when you're integrating U to the n plus 1, U to the n.
Oh, yeah, yeah, yeah. Oh my
Okay,
gosh.
add 1 to it and divide by it. So this is U to the n divided by, I think you got it, but I'm gonna finish it for those who don't know the answer. U to the n du. It becomes U to the n plus 1. You add 1 to it and you divide by n plus 1. So here it was -1, so you divide it by -1. All righty, guys, that's it for today.